The rise of thinking machines, exploring the intersection of AI and quantum computing. Artificial intelligence, or AI, is rapidly evolving. It is changing how we live, work, and interact with the world. At the heart of this revolution lies a simple yet powerful concept: pattern recognition. AI systems, in their current form, excel at identifying patterns in vast datasets. They use these patterns to make predictions and decisions. Imagine an AI that can diagnose diseases with greater accuracy than human doctors simply by analyzing medical images and patient data. This is the promise of AI, a future where machines can perform complex tasks, freeing us to focus on higher-level endeavors. However, there's a catch. Current AI, often referred to as nominalistic AI, operates on a superficial level. It identifies patterns but lacks a deeper understanding of the relationships between those patterns. It's like a student who can memorize formulas but struggles to grasp the underlying principles. This lack of relational understanding, while not immediately apparent in simple tasks, becomes a significant concern when AI is entrusted with more complex decision-making. Enter quantum computing, a revolutionary technology poised to unleash unprecedented processing power. Unlike classical computers, which store information as bits representing 0 or 1, quantum computers utilize qubits. Qubits leverage the principles of quantum mechanics, allowing them to exist in a superposition representing both 0 and 1 simultaneously. This unique property enables quantum computers to perform calculations at speeds that dwarf even the most powerful classical computers. Particularly for specific problem types, the implications for AI are profound. Imagine a nominalistic AI, already adept at pattern recognition, supercharged with the processing power of a quantum computer. It could analyze and interpret data at an unprecedented scale, making connections and identifying patterns that would remain hidden from even the most sophisticated classical AI systems. The perils of nominalism: how quantum computing can amplify AI's shortcomings. While the fusion of quantum computing and AI holds immense promise, it also amplifies the risks inherent in nominalistic AI. Imagine an AI tasked with managing a country's critical infrastructure, such as power grids and traffic flow. Equipped with quantum computing, it could analyze vast datasets from sensors and control systems, identifying patterns and optimizing efficiency with unparalleled precision. However, without a deeper understanding of the social, economic, and environmental factors at play, its decisions could have unintended consequences. For instance, it might prioritize energy efficiency over social equity, inadvertently disadvantaging certain communities. This lack of relational understanding stems from the fundamental nature of nominalistic AI. It views the world as a collection of discrete data points, devoid of inherent meaning or connection. It's like trying to understand a symphony by analyzing the frequency and amplitude of each individual note, while ignoring the melody, harmony, and emotional context that give the music its true meaning. This approach, while effective for certain tasks like image recognition or natural language processing, falls short when applied to complex, real-world scenarios where context and relationships are paramount. The immense processing power of quantum computing could exacerbate this issue. A nominalistic AI amplified by quantum computing might become incredibly efficient at identifying patterns and making decisions based on those patterns, even when those patterns are spurious or lack meaningful context. It's like giving a powerful engine to a car without a steering wheel. It might move incredibly fast, but without direction or control, the consequences could be disastrous. Two visions of reality: Bohr's complementarity and Bohm's implicate order. To understand the potential dangers of supercharged nominalistic AI, it's helpful to consider two contrasting philosophical perspectives on the nature of reality: Niels Bohr's complementarity principle and David Bohm's concept of the implicate order. Bohr, a pioneer in quantum mechanics, argued that the wave-like and particle-like aspects of reality, though seemingly contradictory, are complementary descriptions of the same underlying phenomenon. This principle, known as complementarity, suggests that our understanding of reality is inherently limited by our chosen perspective. Just as a coin can appear as either heads or tails depending on how it's flipped, so too can quantum phenomena exhibit different properties depending on how they are measured. Bohm, on the other hand, proposed a more holistic view of reality. He argued that the universe is an interconnected web, with all parts inherently linked in a dynamic and ever-evolving whole. He called this interconnected web the implicate order, suggesting that our perceived reality emerges from a deeper, hidden order. In this view, seemingly separate entities are not truly independent, but rather expressions of a single underlying reality. These contrasting perspectives offer valuable insights into the challenges of developing ethical and reliable AI. Nominalistic AI, with its focus on isolated data points and patterns, aligns more closely with Bohr's complementarity principle. It sees the world as a collection of separate, measurable entities, much like the distinct outcomes of a coin toss. This approach, while useful for specific tasks, fails to capture the interconnectedness and relationally emergent differences that characterize complex systems. Section 4. Evrostics AI, a step towards holistic artificial intelligence. In contrast to nominalistic AI, a new approach called Evrostics AI seeks to bridge the gap between data and meaning by incorporating principles of relationality and emergence. Inspired by Bohm's implicate order, Evrostics AI aims to develop AI systems that can not only recognize patterns, but also understand the underlying relationships and contexts that give those patterns meaning. Imagine an AI that can understand the emotional impact of a news article on its readers, not just by analyzing keywords and sentiment, but by grasping the underlying social and cultural relationally emergent differences that shape human understanding. Evrostics AI represents a paradigm shift in artificial intelligence, moving beyond the limitations of nominalistic approaches and towards a more holistic understanding of the world. It recognizes that true intelligence lies not just in processing information, but in comprehending its meaning and significance within a broader context. By embracing relationality and emergence, Evrostics AI aims to create AI systems that are not only powerful, but also ethical, reliable, and aligned with human values. Section 5. Relationality, the key to ethical and meaningful AI. The importance of relational understanding in AI cannot be overstated. As AI systems become increasingly integrated into our lives, from healthcare to finance to transportation, it's crucial that they operate with a level of understanding that goes beyond superficial pattern recognition. We need AI that can grasp the relationally emergent differences of human values, ethics, and social dynamics. We need AI that can understand the consequences of its actions, not just in terms of immediate outcomes, but also in terms of their broader impact on individuals, communities, and the environment. This is where the concept of relationality becomes paramount. Relationality in the context of AI refers to the ability of an AI system to understand and reason about relationships between entities, concepts, and events. It's about moving beyond the isolated data points and recognizing the interconnectedness that defines our world. A relational AI, for instance, would understand that a traffic jam is not just a collection of slow-moving cars, but a complex event with social, economic, and environmental implications. It would consider the impact of its decisions on commuters, businesses, and air quality, not just on traffic flow. Section 6. Conclusion. Navigating the future of AI in a quantum world. The convergence of AI and quantum computing presents both unprecedented opportunities and significant risks. While quantum computing has the potential to revolutionize AI, amplifying its capabilities in ways we can only begin to imagine, it also has the potential to exacerbate the shortcomings of nominalistic AI. The key to navigating this uncertain future lies in embracing a more holistic approach to AI, one that recognizes the importance of relational understanding, context, and emergence. By developing AI systems that can not only process information, but also comprehend its meaning, we can harness the power of quantum computing while mitigating the risks. The future of AI is not just about building smarter machines. It's about building wiser machines, machines that understand not just the what, but also the why. It's about creating AI that works in harmony with human values, enhancing our lives while respecting our humanity. As we stand on the cusp of this technological revolution, it's our responsibility to ensure that the AI we create reflects the best of our aspirations, not just our technical prowess.